how can we algebraically rewrite this in the form a plus bi so that we have no fraction? That's exactly what we did here, but notice in this situation, in the expression in question number 4, there was only one item on the bottom. Here we have a complex value that has a real and imaginary. So what we're going to do is we're going to multiply by what's called the conjugate of that. And just like I shared with you in video number 4, if you haven't watched it, please watch that short video. If you take a value and you take the numerator and the denominator by the exact same value, then 3 over 2 becomes 15 over 10. 15 over 10 is 1.5, as well as 3 halves is equivalent to 1.5. It doesn't change the original expression if the top and the bottom are the same. So using that concept, I want to eliminate the denominator so we can be in the form real plus imaginary for this complex number. So I'm going to write down the denominator, but I'm going to write down what the conjugate is. So instead of 2 plus I, it's 2 subtract I. Okay, then I'm going to come off to the side. You may choose to distribute by foiling. You may choose to distribute by foiling. So feel free to go ahead and do that. I'll demonstrate how to foil the top. So foiling is front, outside, inside, left. So multiply the fronts to get 6. Multiply the outside to get a negative 3i. Multiply the insides to have a positive 10i. And then multiply the last. Well, that's 5 times negative 1 is negative 5. But notice there's 2 i's, which would be I squared. But I'm going to be lazy. Instead of writing I squared, I know I squared is equivalent to negative 1. I'll come back to this later. That's one way to do it. Or you can choose to make your little box. Here's 2i. Then this 2i can go on top or it can go on the vertical side. And then here's 2 minus I. 2 times 2 is 4. 2 times I is 2i. 2 times negative I is negative 2i. And negative I times I is negative I squared. But I'm not going to write I squared in this position. I'm going to write negative 1. Remember, this negative comes from what's in front of the I. I squared is equivalent to negative 1. These are additive inverses. They cancel out. And I'm left with 4 minus a negative 1, which is the same as 4 plus 1, or 5. I'm trying to find another way for us to express this. And in doing so, we can have a fraction, but it cannot have any i's in the denominator. Notice how there's an I in this denominator and there's an I in this denominator. So if there is a fraction, it has to be a real number on the bottom. Okay, here we go. On this top portion, let's combine the reals. 6 and negative 5 times negative 1 is positive 5. So 6 and 5 is 11. So I have 11. Negative 3 and positive 10 is going to give us positive 7i, and then denominator is 5. So we want to split this apart. So it's going to go underneath the 11 and then also the denominator of the 7. So here it is. 11 over 5 is the real portion plus 7/5 I. Real and imaginary of this complex number.